So I was just briefing like why data engineer, role of a data engineer, Azure data engineering products or services, job market of a data engineer, right? Yes. Cloud is majorly, okay, I was saying like cloud is majorly utilized. Just I'll take 2 minutes what we discussed in the last session. It is majorly utilized. Cloud is majorly utilized, right? For storing, analyzing, and delivering data in various form. Data engineer with the help of cloud services, they work on the data and make it structured and useful. They make it structured and useful. On premises, we need to set up your own hardware infrastructure, OS installation, purchasing of database license, installation of database server, designing of database objects. And to maintain all this, right, we require separate teams, hardware team, operating system team, networking team, security team, data administrator, right? But here everything in the cloud, we no need to maintain all this. We need to maintain any infrastructure or licenses, all this, right? So data engineer is responsible for the smooth data flow from the source to destination. For the small data flow from the source to destination, right? Data engineer responsible for preparing the data, cleansing the data, like transforming data and processing the data, right? Data scientist strategizes for the future and analyzes the data, identify the patterns and recommendations for the future. Data scientist is going to recommend for the future, and data analyst summarizes the past, analyze the data, and visualize the data. Data engineer does all the groundwork for data scientist and analyst. Data engineer does all the groundwork for data scientist and analyst. More than 80% of data analysis work, more than 80% of data analysis work is done by data engineers. Data engineering, right? Data engineering. What is the sources of the data? What is the format of the data? How to transform data and what is the destination of the data? And why Azure data engineer is in demand today, right? And the role of Azure data engineer today. So data engineers, they are going to create a data warehouse for the organizations, the storage of structured and queryable data. They contain data from various sources. Data engineer structures the data, stores it, monitors it into the warehouse. Secondly, data engineer communicates with the data scientist to understand the data requirements. He also communicates with the business team to know the business requirements. Yes. The data engineer keeps constantly processing the data, analyzing the data, and monitoring the data. He's going to create a data pipelines and also make sure that the pipeline is secure and efficient. And if you see the roles of data engineer, designing entire data flow architecture, how the data is flowing, the entire data flow architecture, right? And creates a data warehouse for the storage of analytical data. And the main task of this data engineer, ETL, for ETL, right? Yes. Extracting, transforming, and loading. This is one of the key task of data engineer. Is going to extract data from multiple sources, transform it into structured and queryable form, and load the data into company storage service for the further business evaluation of the data scientist. Data monitoring. Data engineers make sure that ETL is performed in a proper way. Data security. Data security, right? It's a major responsibility of data engineers. Make sure that data is secure at each step of the process without any data leaks or data exposures. Collaboration and communication with the business team and the data scientist to deliver the data as per the requirements. Analytics. So they need to have strong analytic skills to perform this analysis and automation. Certain things has to be automated like a data extraction process. Azure data engineering products or services. Azure SQL, Azure Data Lake, Azure Synapse, Azure Data Factory, Azure Databricks, Azure Cosmos DB, Azure Streaming, Azure Key Vault. These are the main data engineering products or services. Azure SQL, it's a cloud RDBMS. It is a cloud RDBMS database. One second. Hmm. Azure SQL, it is a cloud RDBMS. It's a cloud RDBMS database of Microsoft in Azure. It is for OLTP operations. End user, it is going to record the end user transactions. Azure Data Lake Storage, distributed file system with unlimited data storage that is in the cloud. That is what data lake. Generally, we are in Hadoop, we have got HDFS, that is on-premise DFS, but Azure Data Lake is a cloud DFS. See, it is a repository of large varieties of structured, unstructured, and semi-structured data. See, if you talk every cloud data lake, okay, I discuss about this data lake before I go with the next. Every cloud data lake provides some benefits. Unlimited data storage, unlimited data storage, right? Secondly, supports all varieties of data. Supports all varieties of data like structured data, semi-structured and unstructured. Supports all varieties of data, structured, semi-structured, and unstructured. Structured data which is arranged in the form of rows and columns like DB tables, Excel files, semi-structured data like XML files, JSON files. Unstructured data like raw text. Chart messages, images, videos, comes as unstructured. So it supports all varieties of data. And one more advantage, but it supports all formats of data. Supports all formats of data like .txt, .csv, .tar, .zip, Parquet. This way supports all formats, right? Here data is in the form of files. Here data in files. Here data in files. If data in files means we cannot set up relationships. We cannot set up relationships. We cannot set up relationships between the files. Between the files. For example, emp.txt file is there. dept.txt file is there. Attendance, sorry, dept, right? Attendance.txt. Salaries.txt. emp.txt, ept.txt, attendance.txt, salaries. Can you maintain set of relationship between these files? Not possible. If data is in tables, you can maintain relationships. Sorry. If data is in tables, we can set up relationships. Using primary key or foreign key. Example, observe these following tables. Orders table is there. Sales transaction is there. Sales transactions. Customers. Products. Orders, sales transactions, customers, products. What is the relationship? So what is the relationship, right? Yes. If we see order of what? A product. Booked for whom? Booked for whom? A customer. Once order confirmed. Once order confirmed. As a transaction. See here, order of what? A product. Product booked for whom? A customer. A customer. Once this is confirmed, it's a transaction. So as we are not unable to maintain relationship in this, so I'm expecting. So I'm expecting a cloud or DBMS, a cloud relational database management system, a cloud or DBMS, right? A cloud or DBMS. The two used for data warehouse. The two used for data warehouse. The two I'm expecting. The two I'm expecting parallel processing. The two I'm expecting parallel processing. That is nothing but Azure Synapse. So here, the two I'm expecting, that is nothing but Azure Synapse. So in the yesterday I was discussing about this Azure Synapse. 1 second. I'll bring it. So I'm expecting a cloud or DBMS, that too used for data warehouse, that too I'm expecting parallel processing, right? That is Azure Synapse. For data warehouse operations, for big data operations, for analytics, for batch processing, for parallel processing. Here we have a database. Here we have a database called Azure Synapse SQL Pool DB. Here we have a database called Azure SQL Pool DB. Simply we say like Synapse DB. What is Synapse DB? What is Synapse DB? Cloud data warehouse. Cloud data warehouse. Azure. What is Synapse DB? It's a cloud data warehouse of Azure. See, when to go for Azure Synapse, when to go for data lake. If data is structured, okay, generally go for Azure Synapse. If data is unstructured or semi-structured, Azure Data Lake can handle this. Right? So Azure Synapse, we have got a database Azure SQL Pool DB. We call it as Synapse DB. It's for data warehouse operations, big data operations, for analytics, for batch processing. Next, like ADF.
So what do you exactly mean by parallel processing? Like,
See, parallel processing means data is going to get distributed across multiple systems, and multiple systems are going to process the data parallelly.
okay.
Yes, here we are going to maintain a cluster, right? Cluster means a group of systems that are interconnected through a network. And what happens, a big data object means will be working with bigger data, huge data, a file consisting of GBs or TBs of data. So that data, if you want very high speed to achieve, the data will be distributed across multiple systems, and multiple systems processing a particular file parallelly.
Oh, okay.
So that entire architecture I'll be discussing with in brief. And coming to this Azure Data Factory. So simply we say like it is a cloud-based ETL, extracting, transforming, and loading. Extracting, transforming, and loading. It's a cloud-based ETL of Microsoft in Azure. It is a data integration service. For example, we, we have got some OLTP systems here. OLTP means online transactional processing systems. And here we have got a data warehouse. What is data? Stores historical data. Examples of OLTP in the case of Azure, it is Azure SQL. And if you come out on premises like Oracle, MySQL, SQL Server, MongoDB. And if you come to this data warehouse, Azure related, Azure Synapse, Azure Synapse, it's a cloud or DBMS for data warehouse purpose. And even if you come to this uh, on-premise like Teradata, Netezza, Vertica, all these are used for data warehouse. Netezza, Vertica. Where this ADF comes, ADF, it doesn't come in OLTP, neither it doesn't come ADF, doesn't come in data warehouse. Between these two, here you can see that, ADF. Between these two, excuse me, between these two, between these OLTP systems, between these warehouse systems, you can see this ADF. So it is a data integration service. It is an integration service between these OLTP systems and data warehouse systems. So what is that? ADF is a integration service. Integration service between the OLTP systems, and data warehouse systems. See, if you see, if all transactions captured, all transactions captured at OLTP systems, How to bring these transactions? How to bring these transactions into warehouse system, into warehouse? We have ETL. So all the transactions are happening at this OLTP systems. How you are bringing that into this warehouse systems? We have ETL for that. By using ETL tools. We have ETL tools like Informatica, Data Stage, Talend. All these are on-premise. They are on-premise ETL tools. They are all-premise ETL tools. But I need a ETL, but I need ETL on cloud, but I need a ETL on cloud. That is what? ADF. But I need a ETL on cloud. That is what? ADF. ADF can connect with using ADF. We can connect with cloud databases, non-cloud databases, NoSQL databases. Using ADF, we can connect with cloud databases, non-cloud databases, NoSQL databases. Right? Yes, fine. Using ADF, we can extract the data, pump the data into this into data lake or Synapse, and then perform transformations. ETL, here it is ETL, extract, transform, load. Extract, transform, load. The ETL, but our working style will be, but our working style, ELT, working style is ELT, extract, load and transform. Extract, load, transform. ETL, generally ETL for small volumes of data. ELT for huge volumes of data. Yes. Yes, ADF is a data integration service between the OLTP and data warehouse systems. It's a cloud-based ETL, extract, transform, and load. Next, Databricks. It is a Apache Spark-based data analytics platform. It is a Apache Spark-based data analytics platform. What is Spark and what is Databricks? Databricks and Azure Databricks. What is Databricks? Provides a Spark cluster. Provides a Spark cluster in cloud. You may ask what is Spark and what is a cluster. So I'll come back to this cluster, but what is Spark first? What is Spark? Spark is the main execution model. What is the main execution engine? What we see here in this data engineering. What is Spark? It is an execution model. It is a very high speed execution model to process big data or huge data. It is a very high speed execution model to process big data or huge data. We see the Spark features. Spark features. In-memory computation, mainly like in-memory computation. In-memory computation means storage and processing both happening within the memory level. Storing within the memory and processing within the memory, because of which very high speed. Supports MPP. Massive parallel process. Massive parallel process. So here very high speed we said, right? Very high speed in-memory computation. Because of this in-memory computation, storage and processing both happening within the memory level. Supports MPP, massive parallel process. Data is distributed across multiple systems, processed by multiple systems parallelly. So if we compare the Spark speed with any other, like for processing systems, right? Spark 100 times faster. Spark 100 times faster than normal disk processing. So as part of our course, we'll be discussing Spark also, right? Unlike other training sets, not like overview, I'll be discussing in brief about the Spark using Python, PySpark, right? along Databricks with PySpark 100 times faster than normal disk processing. So today it is got a great boom, Spark and Spark processing, right? We see Hadoop has got a great speed. Hadoop has got a great speed. For example, Yahoo has conducted a test to check the speed of different data. Yahoo has conducted a test to check the speed of different databases. It has taken a table of 100 TB. It has taken a table of 100 TB consisting of 1024 columns. 1024 columns. Task was sorting based on 16 columns, not on a particular column, based on 16 columns sorting. Generally, sorting based on single column like salary, age, but sorting based on 16 columns of 100 TB. So time taken by different databases. Oracle has taken nearly first Oracle. It has taken nearly 3.5 days to process. Secondly, MySQL to process this. MySQL, it has taken nearly 60. You Teradata, a specialized database used for data warehouse, just 4.5 hours it has taken. Netija just has taken 3 hours. Finally, Hadoop, there is a component Hadoop, the big data, right? Has just taken 3.4 minutes. 3.4 minutes. And later it has taken later in the latest version, it has taken just 1.2 minutes. Hadoop. So here if we compare Oracle, these things, they have taken days of times, this taken hours of time, Hadoop has taken minutes of time. Now, Hadoop has taken 1.2 minutes, then what's Spark speed? Spark is 100 times faster. 100 times faster than Hadoop. Now try to say the speed of Spark now. What will be the Spark speed? Very high speed, right? As compared to this, both Hadoop and Spark combinedly will be used in the market actually, but Spark is 100 times faster. But Spark requires a cluster. Spark requires a cluster to run, which was provided by database. What is a cluster? Group of nodes. Group of nodes means CPUs, systems connected in a network. Group of nodes, CPUs connected in a network. Connected in a network. There are two types of nodes. There are two types of nodes, I mean systems. Master node, driver node we say. Slave node or worker node. In this way, it follows a master slave architecture, not client server architecture, right? Yes. Single master, multiple slaves. Single master, multiple slaves. So in this cloud environment, you no need to take care about all these things. Everything taken care by this cloud itself. It is everything invisible. You need to just select how many you want. How many? This is what a cluster, group of nodes connected in a network. This is what we call it as a cluster. Group of systems connected in a network. One will be the master, first one. Master or driver. All these are the slaves or workers, S2, S3, so on, Sn. Yes. So your file, generally your file or file object, right? It is divided into smaller parts, stored across multiple systems, and are processed parallelly. Yes, the file distributed across multiple systems that are processed parallelly. Everything taken care by the architecture itself, right? We don't need to perform all this. So just you need master or driver, and this slave nodes are worker nodes. So data is distributed. More systems, more speed. Less is, for example, only one system. See, parallel processing, non-parallel processing is, if we discuss about non-parallel and parallel. Non-parallel and parallel, simple, and one labor example. Yes, one person preparing one item, taking 1 minute. The same one person preparing 10 items takes 10 minutes. The same one person preparing 100 items taking 100 minutes. But here in the parallel, one item, 1 minute only. 10 items also 1 minute only. 100 items also 1 minute only, right? Because here 10 persons working parallelly. Here 100 persons working parallelly, right? Okay. So there are two types of nodes, driver and worker nodes. Okay. Assume we have 500 nodes. Assume we have 500 systems, nodes. This 500 nodes, assume this 500 nodes are, find this 500 nodes. Yes. Cluster, 500 nodes cluster is worthy processing 2 TB data at a time. Assume this 500 nodes cluster is worthy processing 2 TB data, 2 TB data at a time. Okay. Assume tomorrow your data volume increased. Your data volume increased. Very simple labor example. Today, a person, right, carrying 5 kg, he can run with that speed. He can run, he can walk fastly, he can run with it. If the data, if it is increased, if it is increased to 10 kg, he can walk. If it is increased to 50 kgs, he cannot even walk, right? Means if the load is increasing, its speed is decreasing, right? If with 1 kg, he can hold and he can run with that. It 5 kg also okay, but 10 kg he can walk with that. But if it increased, means if the data load is increased, right, speed is going to decrease here. So what we are doing here to maintain the speed, right? If we are increasing the systems also, very simple labor example for a building construction. If 50 laborers assigned for the building constructions, 50 laborers, 50 people, if they are assigned, the work goes very fast. In the 50 laborers place, if you are keeping only 5 laborers, very less speed. It goes slowly, the work goes slowly. Or even if you keep only 2 laborers, work goes very, very slow. All right. The same way here, I'm taking our people, but in our context, it is systems. If more systems, more speed. If less systems, less speed. But here, everything you no need to maintain everything in the cloud. Just you say number of systems you can type. I want 10 or 50 or 40. That's it. The entire thing taken care by the cloud itself. We no need to maintain all the infrastructure licenses, that all this install all nothing. Everything taken care, right? Yes. For example, your data volume increased. If same cluster is used, if same cluster used, hmm, speed goes down, right? Speed goes down as data volume increased. So we need to scale up. So we need to scale up. We need to scale up the cluster by adding new nodes. Hundred nodes added. Assume that okay, this 500 nodes okay. Previously it was working, but your data, your customers increased by 100 times, data increased by 1000 times, right? But still you cannot go with the same number of systems as you did previously. So we need to scale up the cluster by adding some new nodes. 100 new nodes added. 100 nodes added. Okay. After 2 months, again 100 nodes added. You will keep on adding that every time data increasing, you are adding the nodes. Yes. Every time, observe here, every time scaling up your physical data center, physical data, every time scaling up your physical data center is a complex task, right? Yes. So that's why what I'm expecting. So I'm expecting. So I need the same cluster, the same cluster in cloud, and that too, and that too with auto scaling capability. Auto scaling means whenever data increased, automatically it has to increase the systems. Whenever there are less data, we can decrease the systems. Means number of nodes has to increase automatically, right? Whenever the data volume is high. Otherwise, again comes to the normal point. Who is providing this? Who is providing this? Databricks. Who is providing this means Databricks. So what is Databricks? Spark Cloud Cluster. Spark Cloud Cluster with auto scaling feature. With auto scaling feature. Spark Cloud Cluster with auto scaling feature. For example, right now, today my data loader. Today my data loader requires 100 nodes. Think it requires 100 nodes. Tomorrow data volume increased. It has to be extended to 200 automatically. It has to extend it to 200 automatically. Tomorrow data volume increase. It has to be extended to 200 automatically. After processing is completed, again it has to revert back to 100 nodes. After processing is complete, again it has to revert back to 100 nodes. This is general Databricks. This is general Databricks. It cannot interact. It cannot interact. Azure Storage Services. It cannot interact with my Azure Storage Services. Azure Storage Services, just now I discussed it, Azure SQL, Azure Data Lake, Azure Synapse. That's why Microsoft, it cannot interact means it is not it cannot interact with my Azure Storage Services means it is not compatible. It is not compatible with all Azure services. That's why Microsoft and Databricks collaboratively launched a new product called Azure Databricks ADB. What is Azure Databricks? It is a Spark cluster. It is a Spark cluster with auto scaling and compatible with all data storage, with all Azure data storage services. and compatible with all Azure data storage services. Okay, but this is what Azure Databricks. So majorly we'll be discussing about this Azure Databricks in brief. ADF I said, right? It's a zero coding ETL. No coding is involved for ADF. Azure Databricks and with Spark. Spark with Python implementation I'll be discussing major discussion and Azure Synapse. This Azure Synapse, right? Yes. I was discussing here, right, in the test class. So this is major Azure Data Factory. No coding is involved. Everyone can update. Azure Databricks provides a Spark cluster, right? Right. That is Spark with Python, PySpark, Azure Synapse, and also you'll be getting the knowledge about these things, right? Yes, you can just go to the course content. In brief, in depth, we will be discussing with many practical examples, working examples, right? So anybody can update with this. It won't be very complex. Azure Data Factory, this pipelines, linker services, data sets, activities, triggers, in the source control, and nearly 50 exercises I'll be discussing, right? And check with it. ADF. Coming to Databricks, I'll be giving knowledge on this big data, Hadoop, Spark. Before I go with the actual introduction to this Azure, everything about the cloud platform also, I'll be giving the basics of it. This cluster management, Databricks services, delting, creating, right, clusters, types of clusters, Databricks utilities, Databricks integration with different files, and Databricks with different storage systems, Databricks batch processing, Databricks streaming, data like Delta, creating Delta tables, working with Delta tables, right, and Azure Synapse. Overview of tools in Azure Synapse Analytics. Yes, Azure Synapse Analytics, Azure Storage Account integration with Azure Synapse, SQL database integration, incremental load, logging and notifications, deep dive into copy activity, data flow introduction, Spark pool introduction, right? Yes. Yes. So you'll be, I said, right? Yes. You'll be getting the each and every recorded session to your Google Drive, soft copy of these notes, a WhatsApp group for technical discussions, previous interview questions, right? Assignments and tasks to work with, right? Yeah. The timing will be the same timing, 9 to 10 daily. Yes. Tomorrow also people can attend to see more discussion on this. Tomorrow you can attend, but from day after tomorrow, there will be a change in the link, right? So you can see in the chart, you can see in the chart about the course content. They have posted the course content. If anyone, if you didn't attend yesterday session, there is a demo video, right? The link is given. The first 2 3 video they'll be kept in that will be kept in the YouTube, right? That YouTube access will be given for the first, but later it will be given to your Google Drive. You can see the area of content, ADB, Azure data, total Azure data engineering funds. Yes,
So,
you can see there.
will we be performing any end-to-end project as a part of this? Okay.
At the last, I'll be discussing one flow.
Oh, okay.
And this details, payment details, other things is posted in this, right? In the chart, Zoom chart, you can check with that. The contact details of the online team, payment details, right? The other things is kept. Fine. Okay. Fine. So tomorrow we'll continuation from here. Yes. Fine. Any other queries, right? Anyway. Yeah. So I'm stopping for here. We'll continue tomorrow, same time at 9 o'clock using the same link. Thank you.